All right, everybody, welcome to the stream. Um, yeah, Robot Glock, I like your name. Um, Before the stream, I typically just like to um, spend some time just getting ready for the stream. Um, and it seems really silly to just put up a starting soon screen. And I don't care if you guys watch what I'm doing in the background. If I do, then I'll typically cover it. But for what we're doing here, I think it was good to show everybody. Um, First of all, welcome to the stream. I I really debated doing LLM stuff today, and the big reason for that is I'm right in the middle of I've never I've owned Factorio forever. I've like in the original 1.0, I launched a rocket. Right, that's the end of the game. I've never been to another planet um, in Factorio. Factorio 2 and 2.1 is coming out soon and changes a bunch of stuff. Um, so the past week I haven't done a whole bunch of coding. Instead, I've been focused on getting to another planet. And yesterday, I just built the ship that I wanted to test to go to another planet. Um, and it's I'm headed to Volcanus, is the planet that I decided to go to. Um, and I really wanted to do that today. I was debating, man, do I just stream me going to Volcanus on my programming stream? But I don't know. One of the things that's interesting here is we can see that ingestion is really, really slow. Hey, Sky Zero, welcome to the stream, man. Um, Summer is a bit off and on for me anyway. Just a bunch of stuff goes on, but I wanted to make sure. I was really excited. I was really excited for these ternary LLMs. Um, and the crazy thing about this is they claim that this behaves the same as Qwen 27B, so a 27 billion parameter model. I can't even run a quantized, like a 4-bit quantized 27 billion parameter model on my machine. You can see I've got 100K context going on, and I'm fitting the entire model inside of 7.7 gigs of RAM, which is crazy. And these models are designed to run on your CPU, so that you don't even need a GPU for these models. The thing that I'm struggling with the most right now is um, dealing with the ingestion. The ingestion you guys have seen before is pretty slow, but I'm not using much memory. My CPU is, fairly happy. My GPU, it's generating tokens right now. You can see that right here. So you can see my GPU is kicking up as it generates tokens. But one of the interesting things about this model is for whatever reason, it's using GPU 0 also, and it uses a little bit of CPU. Um, you guys let me know. So notice immediately it finished generating. So my CPU just dropped. My GPU 0, my integrated graphics card just dropped, and GPU 1 is now doing stuff for the streaming, right? So we can see that it finished and all this stuff dropped. But it's still fitting within a ridiculously small amount of RAM. I don't know why this model uses GPU 0. Most other GGUFs, when you use them, never touch GPU 0. So I'm not sure why it splits across all of these. And it could be a new update to Cobalt, which I used to run my stuff. But we'll see. Hey, Ola and Michael, welcome to the stream. What do you think of the new Angular 1-year major? I saw that. Uh, it tells me that that we're to a point in Angular where they feel like it's mostly stable is a conclusion that I would draw from that. And going to a once a year release tells me that they want to focus on keeping Angular relevant, but there's probably something else going on behind the scenes that they also want to focus on. I'm not going to speculate on what that is or what that could possibly what could possibly be causing that. But yeah, that's my speculation. My puppy is helping me with the stream. She is. Hey, Indy, come here. Come say hi. Yeah, they're playing right now. So, I'll let you guys see. This is Indy. There's a chair like that way from me in the corner of the room by the window. She likes to sit there and watch people come and go. But she's a sweetie. She's just a micro mini golden doodle. And Sunny is around here somewhere. Sunny is our puppy. She's about 6 months old. She's as big as Indy, and she is a menace. Love her to death, but the two of them together are a bit crazy. Let me know if it gets distracting, and I can close my office. But I'm the only one home, so they want to be near me. So we've been using this model, this tiny model, since the beginning of the stream. I asked it to, use the 80K LLMs.txt, and we can see here if we hover that, it still thinks we have 144K context. That's fine. We're using 31K of our context. So after the last stream, Featherless became much more strict on their 32K context. So even models that say that they give much more context only give 32K context on Featherless. So there's a lot more compacting and stuff going on. Maybe we'll take a look at DeepSeek Pro and GLM 5.2 towards the end of the stream also, just depending on what we get to today. I was really excited about the ternary models, and just wanted to talk and experiment with those. I haven't experimented with them. Everything I'm doing today is brand new to me. So like I said, I've been playing Factorio. And if you guys, for like software engineers, for coders and stuff, I find Factorio to be very addictive. It's a fun way to represent code. And coding processes, and think about throughput and streams and different types of context. I find it a very zen way to also level up the way I think about things. So if you guys haven't tried it, you might give it a look. It's a great game. It's been on my mind all week. Anyway, we're using 31K of our context window. Which would put us right at the edge of what we were using before. And a lot of that's coming from our tool definitions and our system instructions. So we're still within the 100K context that I set this model up with. It's going to try for 144K. I don't want to restart it, but I do want to see. So I made it ingest the LLMs.txt. Actually, let's back up from there first. Let's go take a look at what a ternary model is. And they're becoming more and more of these ternary models. And ternary models are basically a 1-bit implementation. And there's this paper out there. I don't really understand the paper that well. I need to digest it better. But these ternary models make some crazy. So Bonsai is the first release ternary model. The Prism ML is a group that made Bonsai work on GGUF. And a GGUF, they basically wrapped it so it'll work with CUDA. And it will work with Llama C++, like Llama CPP. I'm using Cobalt CPP, which implements Llama CPP underneath and wraps it with some nice stuff. So CUDA is basically your graphics cards. But they're saying that this is 9.4 times smaller than FP16. FP16 is the floating point 16. This is the way most of your LLMs are generated. They use 16-bit floating point numbers for all the vectors that they use to resolve the tokens. It's retains 95% of the FP16 intelligence, which is a crazy thing to say with being that much smaller. And they're saying that this model can generate 26 tokens per second on an Apple M5 Pro. So if you guys want to go experiment, and you guys have Apple, I code on Windows personally. I have Apple at work, but if you wanted to run this on Apple, you go to Hugging Face, you can look up Ternary Bonsai, and this will run on your M5 Pro, and it will take, if you set it up to run, let's grab this again. So I have my context quantized to 5.1, and it's taking up 7 gigs of RAM. So you could run this on your Apple M5 Pro, MacBook Pro, and or Apple M5 Pro laptop, right? And it would take up less than 8 gigs of RAM. You'd have 100K context, and it's saying you can do 26 tokens per second, which is pretty good. Does it give us stats on the token generation here? So I'm getting 51 tokens per second here. This is the file that this is the LLMs.txt that it just ingested. Does it give me stats on this? So it processed at 51 tokens per second, but it generated at 11 tokens per second. So 51 tokens per second is not bad. Here it processed at 24 tokens per second. So I'm getting 11 tokens per second in generation, which is okay. I mean, it's okay for what we're like. If you have an Apple and you don't want to pay for, credits or whatever, and you want a fairly decent reasoning model, Qwen seems to be okay. And this one runs in so little RAM, it's probably worth experimenting with. So after we did this fetch, it's telling us that it's an abstract class. There is no Cobalt LLM. Let's just ask it really quick, and then we'll try a different model using the can you give me a suggestion for how to fix this issue using the docs I just provided? So let's see. This will probably take a little while for it to figure out. So it's processing the prompt in batches. I have the batches set up at 512. So we'll take a look at that. So it processed all that. Now it's generating. And this is the difficult part about streaming, because by myself I would probably have something up on the other screen, watch some YouTube, do something else, right, while this is going on. So it processed 1,054 tokens at 53 tokens per second. That took 20 seconds, right? So it is processing fairly fast, but it's taking time. So there's some other stuff we can do, but it looks like to really improve the speed, we would need to improve the speed at which it can process. 53 tokens per second while I'm streaming and stuff is not bad. Generating at 11 tokens per second is also not bad, right? It's not horrible, but when you're looking at like these giant models out there, that are hosted, and they have a ton of processing power and stuff like that, they can ingest and generate at hundreds or thousands of tokens per second. And so this is one of the realities of working with local stuff. And again, we can see as this is running, my GPU is, it's at 91%. It's working pretty hard. My Intel GPU is also at 87%. It's working pretty hard. And my CPU has jumped up to 50%. It's okay, right? So the other thing we can see is like my temps are going up. That's a 66. Yeah, so my GPU is producing a lot of heat. And when you start running GPUs locally, that's one of the things you'll notice is that they produce a lot of heat when they work. Similar to gaming would be. Actually, it's probably a little bit easier on your GPU than gaming, because it gets downtime. Anyway, the issue is likely due to using the abstract base LLM class directly. It's still saying to use a Cobalt LLM, but I don't think that there is a Cobalt LLM. I also don't see so it's not really picking things up. Let's get this to work. So let's go take a look at the Google 80K here. And so Gemini, Gemma, Claude. So there is an OLLAMA and there's a light LLM. Tools such as VLLM. So there is a Gemini model. It just uses that. Gemma, it can use Google Gemma. Claude So here, ESP stuffed into a laptop. Ran Llama C++ CPP is probably the best, fastest way to run models locally. Yeah, Llama CPP is pretty good. Ollama is pretty good. Cobalt is what I use. It actually it wraps Llama CPP. Let's see what link you posted here. Let me see what link you posted. Deleted all your messages too? Let me, I'm just gonna go. I apologize for the timeout here. Okay. We'll stop timing users out. I apologize for that, Kino. Kino. We'll see if that prevents stuff there, but it looks, you got blocked for the link, but it should be back at this point. Let's see, that, and that. Okay. So what I'm trying to figure out, so LLM agent, Anthropic on an agent platform, open models on agent platform. See, I think Ollama is a tool that lets you host and runs. So it uses the light LLM. So here we can see that we're using some models. So let's give it one last chance and then we'll try a new model, right? It looks like I'm supposed to use light LLM to use this model instead of base LLM. How would I do that in TypeScript? Right. So let's see if it can figure it out. But I think we just replace this with light LLM. So it's going through all of the context that it has. It processed the batch and now it's generating a response. So again, processed at 42 tokens per second, generated at 10, and now it's generating this output. So we're getting the reasoning output right now. So the user is asking to use light LLM instead of base LLM in TypeScript. So now it's checking that. The assistant is suggested using Cobalt LLM as the implementation, but the user is now asking about light LLM. The package includes various models. So maybe there's a typo or confusion. So already it's getting confused here. Google's ADK packages documentation might have, for example, if the user is using a different model like Light LLM, blah, 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 blah. So this is one of the things that I've noticed about Qwen. It's using Cobalt LLM as the model. And so we're actually using Cobalt to do this, right? So we're using Cobalt on both. We're using Cobalt in the in VS Code, but we're also trying to use it in our agent. And it's getting stuck. Like it just seems to be stuck over and over again. So it's gotten stuck in a circular reasoning. And now it's saying, hey, no response was returned. You got stuck in circular reasoning. I want a TS implementation using Light LLM package. It is compatible with Cobalt. So let's give it some more context and see what it does. So it's processing the 558 tokens. That's probably my input here. It's using a whole bunch of context that it's already ingested. And this is part of why I want to finish now, using this instead of swapping models, but we'll swap to a bigger implementation of these. This is the smallest implementation. So let's see what we're doing here. Oh, now it's getting, oh no. First I need to check if the Light LLM package is available. I should verify Google ADK, Google ADK. Import Light LLM from Light LLM. No, but the user's code is currently using base LLM. And it looks like we're stuck in a circular reasoning loop. Again. So let's just see here if we can just do Light. No. Okay. Well, this tool is obviously failing. So what we're going to do is we're just going to kill it. And we're going to go back and we're going to launch Cobalt again. Cobalt wraps, it wraps Llama CPP. And you can see that there's a whole bunch of stuff here. But one of the things that Cobalt does is it also provides a web interface. So you can use that if you want. We're gonna turn that off. We're using CUDA, but if you want to use Cobalt or something like it, and you want to run it on your CPU, you can tell it to use a CPU, or you can tell it to use Vulkan if you don't have an NVIDIA card, stuff like that. We're now going to look at the models. So we tried Quithos and Qwen in the past. We were just using this ternary Banzai 8 billion parameter TQ 2.0. it's ridiculously small for what we were getting out of it. So I downloaded two other ones. So this is the BF16 wrapped as a GGUF. It's a lot bigger. So we're going to open this one. We're going to need to do some stuff to the context. We're going to try and give it 147 context, but to do that, we're going to go down to a 4.0. That should shrink our context even smaller. I'm also going to try, let's not do smart cache. I don't want to chew up a bunch of RAM. If I experimenting on my own, I think I'm going to experiment with smart cache. You know what, before we go that big, let's just go for 100K context. So we'll set it to 100K, similar to what we had before. We're going to go with this with a quantized cache. So at full FP16, this would probably take, I mean, gigs. It's going to take gigs either way. But at Q8, it cuts FP16 in half. So we're using the BF16 model. So it's a way to change the floating points for importance. We're going to go, we were using Q51, and at 100K, that was taking 5 gigs of RAM. But this model takes about 8, so we need to shrink it just a little bit more. So we're going to shrink it. So we're using the DSpark model. And I forget what the DSpark was for, but this is a much bigger version of the model, and it's specifically designed for CUDA. So I'm hoping that makes some changes. The other one that I have in there is supposed to block repetition. So that's the other model I want to try out, and then we'll move on to something. Something different. What I'll probably do is launch the smaller model with like maybe like a 32K or 64K context, and we'll use that to run our agents off of, if we can get our agents to run off of this model. Okay, well, that model doesn't work. Well, it doesn't work on CUDA. Let's try again. We'll try running it on the CPU. So I'm going to run it on my CPU. We're going to set our context again to 100K. We are going to quantize this. We're going to quantize it Q51 again, because I have much more RAM, and we're going to launch it and see what happens. Still crashing. So I can't run that one in Cobalt. Let's try another one. So this is the anti-doom. It's supposed to be the one that fixes the repetition. It's also quantized at 2. So with the reason this one is so small is it's quantized at 1.6, I think. This one's quantized at 2, which allows better. This one is 2. They allow the GPU to perform better. So we're going to try this one. We are, instead of, well, let's go ahead and let's set the context, because if it works, I don't want to relaunch it. So there we go. We're going to quantize down to Q4, and we're going to launch, and we're failing again. Okay. I don't know why those ones are failing. So let's instead, we know that this one works. we're just going to give it like 32K, and that works. All the rest I don't really even care about, because we're just going to use this one specifically. We're going to use it specifically on the for the tool. And if you guys are curious, this is what you get when you set it up. So it gives you this chat interface, and you can chat with it. You can just be like, hey, model, how are you? And, you know, it's got to think about that. Right? So it's like, I could try to respond in a way that's helpful and friendly. And so you can see it's getting streaming responses back. It's doing all of this stuff, but it's reasoning about, like, this is a crazy thing about reasoning models is they reason about everything, right? I asked, how are you? And instead of just generating something, and like this model seems to get stuck because like, wait, the user might have a specific context in mind, but I also need to avoid sounding too robotic. Let me think of some other ways to respond, right? Like it's just off, lost, trying to figure out how to just say, hey, I'm fine. Another thought, I can use the same structure as the previous example. I was like, what? So I have a good plan. Here's my response about, hey, I'm just an AI assistant, so I don't have feelings or physical form. Right? But it took this much thought to get to here. This is what I love about these reasoning models. You can be like, pretend you have feelings and try again. Right? Let's see. Let me try this again with more personality. But I might be an AI, but I can definitely act like I have some feelings. What's on your mind today? I'm curious to know, right? What you need help with. So there's that. But that's the UI that it creates, and you can have sessions and you can delete them. If you create a new session, it just wipes the memory. The thing about this is that it's got so many ways to set up your chat interface, right? And I don't even know what a lot of this stuff is. So like, here's a reflection. Here's a chain of thought reflection. So, you know, we could try this. We've got chain of thought set up here, and like, we could just say, give me some JSON to hold user settings in a web app. Think about security when you do. So now we've given it, you know, okay, we've got some JSON, and now it's thinking about that. And right, it's come up with like a username, an email, and dark mode. But wait, security is important, so we probably, you know. Also, the app should never store plain text passwords. We could use bcrypt. So it's just going into a bunch of stuff here about this, you know, JSON and stuff like that. But it's much faster when you're not trying to feed it a ton of context, and it's not having to go through all of that context, right? So it thought less about this, but right, we get username, email, dark mode, theme, and language. Not bad, right? So it's not a bad chat interface. You know, we could use it. What else could we do? You know, we could, should I pick React view or Angular. Let's just see what opinions the model might have. So it's thinking about goals here, spas and stuff like that. React and Vue might be easier to start with. Angular, on the other hand, uses TypeScript as a steep learning curve, but offers better type safety. So it's saying that Angular works for larger scale applications. Virtual DOM. Okay, that didn't help. Right, so obviously I have it set up in the wrong scenario. But yeah, there's a bunch you can do with the chat interface. It behaves just like any of the chat interfaces out there. That's why I like it. You can keep it. You can edit stuff. There's other things you can do that you can provide context files and stuff like that. The big models provide themselves. So we're going to let that be. For now, let's go ahead and swap over to DeepSeek, and let's get a new chat, and let's just tell it to, actually, before we do that, let's DeepSeek, there we go, and under this we want to so we've got this set up at 256K. It can't use that. So we're going to use 100. So that's my local completion. We're going to use this same stuff here. And we're going to use DeepSeek. So we can't go that big, but we can do this big. And we can also change that one just to be safe. So let's see if DeepSeek can help us figure this out. So the first thing we want to do is we just want to web fetch, and we're going to grab the documentation. So here, under coding with AI, it gives us the LLMs.txt. We're not going to go with the full. We're just going to grab this one. So we're going to copy this link. And we're going to put that in there. One thing to be careful of, and this is becoming more and more important as the web grows, but these LLMs.txt could be I don't have anybody using my feather list that I'm aware. So it's giving me a rate limit exceeded. Okay, Well, that's fun. All right. That's too bad. We're going to swap over to anti-gravity. I'm not sure what's going on there. We've had success with that in the past. Let me just go check my feather list really quick. Like, I wish, one of the things I wish I could do is see where it thinks I'm using dedicated, like, models and stuff, but we'll give it some time for whatever it thinks is using it to time out. Um, we're going to use anti-gravity and we'll open up this project. Oh, we're already there. Okay. Um, so yeah, we'll use Gemini Flash Medium. That's fine. Um, how do I fix this code to run a local agent? No, I don't want you reading. Don't read the environment. The issue is a code error with base. So I don't want to give it access to my environment file because I don't want to be sending API keys out to models that I don't control. And that's one of the reasons why running a local model is useful. Is with a local model, you're not sending things out to the internet. Oh, So it's actually um it actually wrote its own wrapper. Is this something that you have to do? And then it uses that. In agent. This is fascinating. Um, so it wants to run tests. We're going to run the tests ourselves. Base LLM is abstract. No native OpenAI provider currently only bundles built-in integrations for Gemini, Google Gen AI SDK, and Apogee. It does not ship with OpenAI compatible subclasses. So it wrote a local AI, OpenAI LLM compatible layer. Um, so out of the box, this tells me that Google's ADK is designed to run Gemini, um, which makes sense, right? But it's a little disappointing. So here, now I should be able to pnpm exec ADK run. Or is it run agent.ts? Is that the right way to do this? I forget how to run it. Um, so AI models for ADK agents, Gemini, Claude, and agent platform. So you have to run it model connectors, Apogee. See, in this, oh, so it's only supported in Python. That's why. Olama is only supported in Python. That's why. So now it's running. So we should see here, if we run this, we should see stuff coming out over here. So now if I'm like, hey, what time or what can you do? right? So now we're getting generations over here. It is, so you're an agent, your internal name is Hello Time Agent. The description about you tells the current time. You're a helpful assistant that tells the current time in a city. Get current time tool for this purpose. So it is generating a lot of information. It's generating 1,500 tokens. Um, um, so the answer should be that I can tell the current time in a specified city. So it did all this reasoning, and it's telling me I can tell the specified time. I can tell time in a specified city using the get current time tool. That's the only function I have. So now what time is it in Buenos Aires? It's going to tell us 10:30. It failed. So it says it has been retrieved. And then it gives me back the current time in Buenos Aires is 10:30. So we get that back. That's expected because the current time, according to our tool, is always 10:30. Which is not a super helpful tool, but that's the way the agent is written. So like, what time is it in the major cities of the, let's just say the major cities of Canada, right? Now let's do the US, because I have better chance of determining if they're major cities in the US, right? So the reasoning we're getting, the user's asking for the major US cities. Let's see which cities it figured out. So it asked for New York. It's outputting a bunch of stuff, generating a whole bunch of tokens again. And more tokens. I'm curious what it's doing. So it only did New York City. I'm curious why. No further tool, no further. So it's getting all this context back. So it asked for New York City. but it's not giving more cities than that. Um, oh, come on. There's so much that it's trying to generate here. I'm not even sure what it's doing at 1,500 tokens. We're gonna give it abbreviations for major cities. Okay. Wow. So the user first asked for Buenos Aires. Um, Tools response. Okay, so it got locked in a reasoning loop. Um, so New York City. Um, I can tell the current time in a specified city. Since the tool can only provide time for one city at a time, I can only provide the time for one city. Please specify which of these cities interests you. The major cities in the US include New York, Los Angeles, Chicago, Houston, Phoenix, San Francisco, and Dallas. So those are good. Therefore, ugh, and then it just stops. Give me the time for, we're going to go London, NYC, LA, we're going to go SLC, OKC, Calgary. What else should we do? And we'll do Melbourne. So let's see. It's probably going to tell me that it can only do one city. And we may have to update the tool to allow us to make multiple calls. It may be stuck in this context that it can only do one city at a time. So it did make the calls, and then it said that it's 10:30 a.m. in all of these cities. It's hilarious that it's trying to figure out why it got 10:30 for all these times. So let's stop that, and we'll come back to it here in a second. So returns the time for a specified city. Here we're going to grab a random hour and minute, const hour equals we're gonna do math floor. We're gonna do that. And then we're going to say the const AM PM. So now that's going to give us a random. Oh, it wants us to pad the minutes too. Sure. So now we've given random times, and now let's try that again, right? So here, oh, dang it. I killed the wrong one. I killed the, we're gonna grab this one. We gave it 32K of context. And that's all we did. And now we're going to run it again. So we're good there. We're good there. Give me the time in NYC, Mexico, DF, Guatemala City, Adelaide, Paris, Bangalore. Just pick some random cities, right? They come off the top of my head, and we'll see what we get. I mean, we're going to get random times. So I'm curious how it handles it this time, because last time it tried to explain why every city was 10:30 a.m. Now we're getting random, reading random values. So it'll be interesting to see. So we can see it called the tool multiple times. So even this small model is really good at calling the tool multiple times. One thing I think I want to do next is look at a different agent tool, like something that creates agents for us. The thing I'm noticing about like anti-gravity and stuff like that is you're locked very much into their ecosystem. So Gemini, Gemma, stuff that they host on their own servers, things like that. As soon as you try to break out of that ecosystem, it becomes much more difficult. And the reason that window won't go away is I didn't turn off the chat interface, and so it was up on another monitor. Things are progressing slowly. So here we go. So we got our reasoning chunk. And then here are the current times in the specified cities. So in New York City, it's 3:41 a.m. In Mexico City, it's 10:59 p.m. In Guatemala City, it's 10 a.m. Adelaide, 11:35 p.m. Paris, 1:51 p.m. And Bangalore, 13:27 a.m. all of those are wrong, but you know, it is better than what we were getting before. And you know, we got these back. So let's exit. And we're gonna pnpm exec 80k run web. Oh no, it's pnpm exec 80k web. So this is coming up on localhost 8000. So we're gonna go here, we're gonna go localhost 8000. So here we go. So our message is, what time is it in SLC, OKC, LA, NYC, and we'll go and Beantown, right? Boston. Let's see how it performs. So it's gonna need, I'm curious if it breaks these up to Salt Lake City, Oklahoma City, Los Angeles, New York City, and Boston. Or if I'm just gonna get random times for these. We can see, and this is the nice thing about running it locally, is we can see that it's reasoning that it needs to call the tools multiple times. The nice thing about local also is that I can generate this agent tool and run it against the local agent and not use credits, or you know, not pay for the development of the agent. Once I get the agent to a place where it works, now I can start using it against like a bigger model. But I think going forward, I'm not sure if I'm going to use the 80K. I would like to be able to use local models easier. Yeah, the other thing I would like to do is experiment, you know, with some of the local models that are hosted on sites like Featherless or things like that. Yeah, this thing is like, the reasoning that it does is very verbose. So it made the function call city SLC OKC LAC. So it did disambiguate them in the output. So SLC Salt Lake City, OKC Oklahoma City, Los Angeles, New York City, and Boston. Yep. So it was able to figure them out. It also gave us a nicer output in the web. We can see all the different tool calls that it made. Here we can see the various tool calls. Like, there's some nice stuff about this. So let's make it actually grab the real time. So to do that, we're going to need to do a couple of things. First of all, Um, I want to say, can we break this up into multiple files? So we're gonna have it break everything up into multiple files for us. Because like this exactly, it's picking out the right stuff to move. So now we're in a better place. And we're also going to say, let's move get current time. We'll leave it for now. We're going to leave it for now. What we need is we need a tool. What do we need? Let's just see if, well, first of all, let's commit this. We definitely want to commit where we are. Because we're going to make some breaking changes. So let us, oh, I didn't merge that into main. That's fine. And we're going to compose all these commits. Whoops, cancel that. We don't need that. What we want is we want the AI to write our commit message. So great, we'll push that. So now we're ready to make some changes. I think we need a tool to we need actually let's give it some context first. So if we go here, or was it here? We're going to use the coding with AI. We're going to grab this. We're going to copy this link. We're going to tell it to web fetch this link. We're going to tell it that we trust adk.dev. So there we go. So how would I make 2 tool calls? One to get the one tool will ask the model for the time zone of the city. The second will call get current time with the city and time zone. So we want to so we can use base LLM. Interesting. So that's how it works. So we'll accept all these changes. So get the time zone, queries the model to find the time zone of a given city. We take the city and then we generate what is the standard time zone of this city, and then respond with only short time zone offset. So it's going to return that, and then get current time. It updated it to use time zone, and it added the time zone too, so we can see what time zones we get. So let's go ahead and run this in the web interface again, because I like that interface better. We're also going to use this same query because I like this query. So we're going to go here. We're going to go here. We're going to refresh to get us a new context. We're going to, again, ask it those cities. And now it should start asking our model. And this is one place where an agent is powerful, because we can have a smaller agent doing the time zones, right? So so the time zones, it's asking for the time zone here. It's calling the tools multiple times. But to finish my thought, when you're building agents like this, you can set your agents up with their own context. And so we can use like a local model or a cheaper model to get the time zones, and then maybe we can use a bigger model to do the bigger reasoning. And this has real implications for like your day-to-day coding. So think about like as you're writing code, what you could do is you could create your own agent, and that agent could do a couple of things. It could take your queries, it could run them through a local model and trim them down for better token efficiency. It could answer some quick things right away, and feed a query into the bigger, more expensive model that you've already reasoned about at a smaller local level or at a cheaper level. So you could do some prompt pre-processing on, the cheaper, quicker models, but then the actual reasoning, maybe you switch to a Claude model that costs money, or one of the bigger models that, is more expensive, and you save money that way. I watched we got MST, So SLC is MST, yeah. So there's a whole bunch of stuff here. But yeah, hard base. Do you feel like AI and LLMs nowadays is like a pay-to-win video game type of thing? If you or your company got money, you were set to go. Otherwise, you're kind of screwed. Um, Man, that is a good analogy. Um, right now in our industry, we're kind of at a race to the bottom, right? Whoever's cheapest wins. And you're not wrong. We're in a pay to win, where it is largely the haves versus the have-nots, right? Um, Companies with a lot of money are going to be able to afford it. Individuals with a lot of money are going to be able to afford it. Um, like one of the things, if we take a look here, like I've liked featherless for a long time because they're fairly cheap, right? But think about this: it's $25 a month, and this gives me 32K of context. To go to 256K of context, I have to move up to something that costs me $100 a month. And notice here it says no limit on size, but here it says any model up to 229 billion parameters. So there's difference here too. And here you're getting DeepSeek, Kimi, and GLM. I'm not sure if this one does. To go to the no limit on size with 8 current connections, 256K context, 1 agent runtime, and persistent storage, it's $200 a month. And think about what that represents. That's that's $2,400 a year. This is $1,200 a year. This by itself is $300 a year. I'm paying just to run models. It's not cheap. Like if I wanted to move to this tier, I can't. I'm not even sure I can run. I can't run DeepSeek, Kimi, and GLM because they're bigger than 229 billion parameters. So these models I can't run, but I'm limited to 32K context at this tier, and they started enforcing this pretty heavily. And like, if I go to my wife and I'm like, "Hey, wife, I want to spend $1,200 running models," she's gonna be like, "What happened to you?" Right? Like, what's wrong with you? Um, and it's just as bad when you go into like the credits and things like that. So then we're into a place where we were looking at the beginning of the stream, where we're running models locally, but then it's hardware, right? And electricity and cooling costs and all of those costs. So it doesn't matter what you do with AI, it costs money. Um, it, I think your pay to win strategy or your pay to win analogy is very spot on. It it is, for all intents and purposes, basically where we are. Do you think AI has improved significantly recently, and what do you think will happen to jobs in the future because of AI? Will things get better or worse? Well, so here's the reality of where we are. And even if the majority of people stopped using AI tomorrow, that doesn't mean that AI is gone. All that means is that the people who can't afford AI no longer use AI, and the people who can afford AI use AI. So, like, if tomorrow everybody stopped using AI, you can't tell me that like Elon Musk is not going to use AI. A person who's worth $1 trillion is going to use AI if they want to use AI, right? So AI is here to stay. What does that mean for the industry? Well, one of the things I've been telling people, and this one depressed me for a long time. Um, and when I started realizing this, I was talking to Michael, and I was like, Michael, I don't even know if I want to stream anymore, right? Like I was in a place where I was like, I'm frustrated. The reality is, like I started coding professionally, let's say 1998. I started coding professionally. Um, so I've been doing this for almost 30 years. Um, and even like 3 years ago, 3 years ago, I would have told you that AI could never do what I do. I realized I'm wrong. Um, I realized that something I spent 30 years working on has almost no value in the world today, right? And that's the code. Like the code itself has almost no value. And why do I say that? Well, I say that because when you compare what it costs for an engineer to produce code versus an LLM, the LLM wins hands down. It can run 24/7. Right? The cost that you pay for that LLM versus an engineer is much cheaper. And this is why companies are pushing for LLMs, because engineers have been so expensive. Um, and that's a depressing thought to have. So, what do we think about when we're in that situation? Well, there are some things that LLMs can't do, right? And those are the things that are valuable, and they've always been valuable, um, right? We've just been acting like the code itself is the value that we deliver. It's not. The real value that we deliver is the design, the architecture, um, best practices, things like that. And some of that stuff LLMs do okay. A lot of it they still struggle with. So your job is no longer worrying about the code. Your job is now worrying about, how do I get agents? And when we talk about agents, they're just somebody who can do something for you. Those could be other humans. Those could be AI, right? LLMs. They could be who knows what, right? We don't know what the future holds. But those agents are things that act on behalf of you. How do I get those agents to produce what I need them to produce? And that goes back to best practices, right? That goes back to reviewing what's generated. That goes back to a lot of the other things. And so what you wind up with is this iterative loop where you you instruct it to do something, you let it go do something, and then you check what it did. If what it did is good, then you stop that iteration and you move on to the next iteration and you instruct it to do something else. It's the chain of thought, right? COT is how chain of thought's often abbreviated, but you need to keep your agents focused on one thing, and that's why I'm really interested in building agents, because what if I can build an agent workflow that allows me to set things up, and it gives each agent a right? I could have up to 4 or 5 agents running on a small LLM, and those agents go out there and they're like, "Hey, I'm looking for a specific thing," right? Like maybe I send it out there and say, "Hey, look for linting errors." And my agents just run and look for linting errors, and they collect them. And then once they've collected the linting errors, my next task is, let's fix those linting errors. And so each agent gets an error and it goes off on its own and fixes those, right? And so I've got smaller agents doing specific things, and I'm creating the harness to do it. That's my value, right? Is creating those flows and understanding those flows. Um, my value isn't the code I deliver, and that has some real implications. And when you talk about things like Tailwind, you know, their struggles. When you talk about, you know, Angular going to yearly releases, when you talk about, like, I think those are echoes of what I'm talking about, meaning if I'm having agents do it for me and I'm validating that the agents are doing it correctly, I don't care if the agents do it in Vue, React, or Angular. That doesn't matter, right? And that's a strange thing for an Angular GDE to say, right? Angular doesn't matter. What matters is that I understand what it's doing and the agent understands what it's doing and it has the best chance for success. Those are the three things that matter. And that's where your value comes in, is being able to be that piece that has the experience to go, yeah, there's problems here, right? Because an agent is going to go off and be like, this works and it works because of X, Y, and Z. And you're going to go, oh, yeah, you're leaking passwords here, or you've got a memory leak here, or, right? Like, your job is going to be more the investigative, and you become more of a manager, you become more of an investigator, and less of the hands-on, hey, I'm going to write this code. I think people will write code because there's code that agents can't write. I think, you know, a lot of the research in like compression and things like that, people will still be hands-on keyboards. I think that there still will be a lot of code written, but for like the majority of what companies were paying a lot of money for, UIs and things like that that are largely solved, there's very little value in that code. That code can be generated by an LLM. So yeah, that's my thought. When are you doing a React only stream? Oh, brother, that is a loaded question, man. We'll see. So hard base, same with the learning system. Back in the old days, you could create and learn stuff for free. Any language, any framework, just install on your PC, read the docs, and go. Now you need credit cards to get a set a minimum value. Yeah, if you screw a loop, your $5 vanishes in seconds and you're no longer able to learn and practice. And that is 100% true. Man, you guys are going to pull me into there's an interesting thing going on right now, and you know, when we talk about where's my mouse? It's on the wrong screen. Here we go. So when we talk about most things, right, we've got a pendulum that swings between two extremes, right? And this is the way I look at most things nowadays. And I base this a lot. I really like the Stoic philosophers. And I base this a lot on, you know, what I've read from various Stoics, just personal experience and things like that, right? So you've got two extremes, right? You know, in the classic sci-fi, fantasy, whatever, right? This could be good versus evil. And I'm not saying that one side is evil and one side is good. And this is really difficult to draw letters with a trackball. But the evil side is trying to push the pendulum this way and keep it over here, right? The evil wants things to stay where the evil wants them to stay. The good side, right? And I'm not talking like anything outside of like, you know, your typical fantasy, like, right? Sauron wants the orcs to rule and whatever, right? And the humans and the elves and the dwarves want freedom and blah blah blah, right? So this pendulum swings both ways, and you even see this in the movies, right? Sometimes Sauron wins and the pendulum's over here, and things are horrible for the humans and the elves and the dwarves. Sometimes the humans and the elves and the dwarves win, and the pendulum's over here, and Sauron goes into hiding, and the orcs, right? You don't see orcs and goblins for you, like that. It's part of the lore, right? And that's just kind of the way things work. when we talk about the current state of things, we could talk about like 1980s versus, you know, how things have been for a while, right? We'll call it the thousands, right? And in the thousands, we were a lot more consumer friendly, right? If you go back to the 80s, it was all about like money and Wall Street and all of that stuff, right? And again, let's ignore the good versus evil. I don't want to make judgment calls. It's not my place to get into politics and stuff like that. I'm just pointing out, you know, something that's going on. In this time, the workers had a lot of power, and we made a lot more money, and things were good, right? We're swinging back towards kind of the 80s style, and during the 80s style, you had like The Wolf of Wall Street was a movie released where greed is good. You had Alex P. Keaton, who was, you know, on TV talking about how important it is to make money and greed is good and all this stuff, right? And they're trying to hold the pendulum over here. And we're seeing interesting things. We're seeing stuff like surveillance pricing, which is crazy. We've got data brokers out there that are selling all of your data. That data can then be used to build a profile on you, and your prices will change based on that profile, but you have no idea why they're changing. It's just you're getting a price and somebody else is getting a price, and their price is lower or higher than yours, and you have no idea why that is. But the reality is the companies are making 80% more profit with this surveillance pricing, right? They want it to stay over here because the companies want to make more money. We want it to stay over here because we want to take more money home, and we want to be able to, you know, enjoy life better. And, you know, there's differences going on, right? That's what I'm seeing going on right now, and that's why everything is pay to win. And I really think the video game industry was a way for a lot of these people to try out these ideas, right? Like if you go back to the first kind of microtransaction pay to win, you're looking at, I'm old enough to remember when Oblivion released the first horse armor, right? It's the classic microtransaction. The horse armor for Oblivion, I can't even remember, it was like $20. And all it was armor for your horse. Everybody was up in arms and everybody hated it. Everybody was anti-DLC for a long time. And they kept trying again, and they kept trying again, and they kept trying again. And eventually, now every game releases, and then you expect a DLC, and you expect another DLC, and you expect another DLC. And they got that model in. And then they got the microtransaction model in. And then they got the live service model in, right? And this is consistently degrading your performance as a consumer, and making the company more money. And now the latest like controversy is EA in college football was putting microtransactions into the single player mode. But they're not the first to do it. Like 2K has been doing it forever. Like if you run a My Career or My Story in NBA 2K, they want you to buy credits, right? And it's going to take your character like 10 years to be any good, or you just drop $100 after you buy $100 game, and suddenly your character is good from the beginning, right? Pay to win. And so I think the video game industry was a test bed. They saw what people were willing to accept, and then started moving that into other stuff, and we're kind of paying the price for that now. How can an AI LLM help me with not eating ice cream? I'm getting fatter and it's getting very hot these days. Dude, switch to gelato. You're in Italy. Gelato's better, man. I don't know. I really don't know. You're asking the wrong person about that. I do enjoy ice cream, and I do enjoy my soda. So there's There's currently only one game, which is currently the only game, which I think is not greedy. You can basically play it for free and you can get everything in the game for free. It's called Warframe. I'm at max level, been playing it for a few years. I've never played Warframe. Bro, gelato means ice cream in a tub. Yeah, it does. It definitely does. And the funny thing is like there are gelato places showing up all over where I am here in Utah. And it's just ice cream, right? It's Italian style ice cream. There's some differences between the way the classical American ice cream's made and gelato's made. But everybody's like, oh, gelato, gelato, it's ice cream. But the one thing I did really enjoy for a long time until they basically COVID made it so nobody could go and eat there, so they had to shut down. It was a place called Vampire Penguin, and they did flavored shaved ice. It was so close to ice cream, but the calories were so much lower. It was such a good place. But yeah. Anyway, yeah. The reality is, we're in a pay to win phase of the pendulum. And the best advice I can give you now is do what you can to survive it. Do what you can to take care of yourself and your family. And the pendulum has to swing the other way eventually. It may not be now. It may be a while. And you need to do what you can do now to set yourself up so that you're not struggling. I mean, struggling's the wrong word. You're going to struggle probably. Everybody struggles all the time with different things. But protect you and yours. That's the best thing you can do right now. Make sure that you're doing everything you can to protect you and yours. And then after that, figure out what you can do to be better. That's the way I look at every day. But yeah. Yeah, the pendulum has to swing back to quality products instead of garbo. I agree with that. And like, I'm a big fan of eating out, and you guys could probably tell that. But I don't eat out as much because the food quality is so horrible. Like, you go and you spend, $20, and the food quality is so horrible, and you don't feel good after eating it. And that wasn't the way it used to be. Food quality was much better, and it's that way with everything. And yeah, it does have to swing back the other way. 2 rounds closer to the job. Good job, Vortson. I'm glad to hear it. Got to grind system design now. It's so over. System design is take this a bit tongue-in-cheek, but system design is basically draw 3 boxes, draw arrows to your desired outcome, right? And then when they ask you questions about the 3 boxes and the arrows, be quick to react to what they're asking. And that's a bit tongue-in-cheek, but it's also not, right? Like, if you can, with system design, if you can put a simple design on the screen and talk through that design knowledgeably, you're never going to be able, like, if you think about a system design interview, in an hour, you're supposed to design a system. Like, the classic system design is like design Twitter, right? Or design Facebook, or like, you're never going to be able to do that in an hour. So go in, narrow the scope first, put your boxes on the screen, draw your arrows from your boxes to other boxes, talk knowledgeably about that. Some of the biggest mistakes that I see people make with system design is they go where they're comfortable. And what do I mean by that? when you're designing a system, it's really easy for you to design like the database, or it's very right, and the tables in the database, or it's very easy for you to get stuck, designing a user interface or things like that. But that's not a system, right? That's a part of the system. That's not the entire system. So stay high level until they ask you to drill in. And one thing to be aware of whenever you guys are doing tech interviews, and always do this, is ask questions. Don't just dive in and, somebody's like, hey, design Twitter, ha ha ha, right? And you're like, oh, great. Well, first we need, no, you've already set yourself up to fail. Instead, be like, well, Twitter's a huge system designed over many years, right? What parts of Twitter do we specifically want to focus on? And let's talk about that, right? And then you can start talking about web. You can start talking about, what should your front end be? Maybe it's web, maybe it's mobile, maybe it's a combination. Are we going to do native, right? Stuff like that. Then we can start talking about our middleware. Are we going to use Java? Are we going to use microservices? Are we going to use blah, 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 right? And have opinions about that, and be willing to back up your opinions. Don't fight with people, but have good reasons why you pick your opinions, right? And then the back end, start talking about, right, is this going to be in AWS? Is this going to be hosted on-prem? Is this going to be blah, blah, blah? And what are the upsides and downsides of that? Always, whenever somebody's like, say you decided to say, my back end is going to be Postgres, right? And they're like, well, why did you pick Postgres? And it's like, well, there's some trade-offs with Postgres. With Postgres, we control blah, 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 but we're giving up, the benefits of cloud, and we're giving up the benefits of this or that, right? We're like, always present things as trade-offs. And every time I've ever been in an interview where somebody does that, I always look on it more favorably. The people that I interview with always look on it more favorably. Yeah, be very, very careful of the pitfall of, oh, they asked me to do something, I'm going to do it right away. If you can establish yourself, right, because a job interview is you understanding the company and the company understanding you. If in the interview you can establish yourself as somebody who asks questions and correctly scopes things, it's a much better, and it's easier for people to want to hire you. So yeah. Design Twitter, buy X and rename it to Twitter. Exactly. First, you need to make $2 trillion so you can buy X from Elon and rename it to back to what it should be. Who cares? Every tech decision is either Angular, React, and Java Spring, with Postgres doing microservices, even when they do not need it. There's some truth to that. But you also have to be careful, because every company's definition of microservice is different from the previous company you worked at and the next company you'll work at. And it's the same with micro front ends. It's the same, like every company has their own definition of things. And that's why it's important when you start talking that, and this goes back to what we were saying before, your charisma matters a lot. Being willing to engage, being willing to talk, being willing to say, hey, you said microservices. Can we define what we mean by microservices? Or if you say microservices and they're like, oh, why are you using microservices? We don't like microservices. That's an opportunity for you to, one, discuss trade-offs, but two, understand their definition of microservices, what you're trying to communicate, and see, why they don't like microservices and stuff like that. And if you're a big microservice fan and you're in an interview and they're like, oh, we don't like microservices, that's a key point of data for you to take away, right? It's not like before where you're like, oh yeah, the interview's over. Don't do that, right? Again, protect you and yours right now. That's your primary concern. But know going into it that you're going to be in a company that has values that are different than yours, right? You like microservices, they don't, right? That's an important piece of the interview process, is to understand what you're walking into. Don't say work, micro front ends. What a good way to ruin my day. Hey, Corpse Revived. Thank you for the follow. I appreciate it. It means a lot. My values are being lazy, work slow, get paid a lot, and not getting fired. Those sound like good values, man. Bill Gates famously once said that, if I have two people to do a task, I'm going to hire the lazy person to do the task because they're going to figure out the easy way to do it. So, they're lazy. There is value in laziness. Thank you for the anytime. Like that. I mean, we're talking about agents, and the reason we're talking about agents, I'm an Angular streamer. I like Angular. It's more than like Angular. I love Angular. I've been doing Angular since Angular JS 0.9. So I jumped from jQuery to Knockout, and then from Knockout to Angular. So I've been doing Angular for a long time. I really like Angular, but the point of the stream is more to help people. I've been in the industry for a long time. You can go look me up on LinkedIn and see what I'm doing right now. And I'm happy to share any advice that I have. I use React. Please don't hate me. I don't hate you, dude. I'm assuming that you're a guy. Dude's non-gendered. Never mind. I'm not going to go down that path, but I don't hate you. Pick the tool that works for you. React works for a lot of people. I've been doing Angular for a long time, and it works for me. But if React works for you, use React. But the other thing that I want to recognize is there's a lot of overlap between React and Vue and Angular and all the other frameworks. And a lot of that overlap is in the way that you build software. And that's the important piece right now, right? The building of the software is way more important than how you write the code or how you get components to the user or how you manage state, or that stuff matters to you as a developer. And it is important, but when you back up and you look at things, the real value that you're generating is you're getting code to, you're getting a service to your users. And that's way more important than if you use React or Angular, right? They'll both get that service to the user, but if you can build a better experience in React, build it in React. If you can build a better experience in Angular, build it in Angular. It doesn't matter, right? Especially with AI agents right now. Where we were just talking earlier, that code, there's very little value in that code and that framework. And that's a tough pill to swallow right now. But the real value is in understanding how software is built, understanding how software gets into the hands of your users, understanding what user feedback means, understanding a lot of stuff, and helping your product owners understand stuff too. There's still a lot of value in that, and that's where your value is today. So again, I'm not going to hate you over that, right? I don't feel good, by the way. I started this Angular job like 3 months ago, and I haven't written actually any Angular, just using LLMs. React devs here. All right, man, you are brave. You're not brave, man. Here's the thing. I've got a bunch of Angular shirts. The part of Utah I live in is called Silicon Slopes. There's a lot of React devs here. I get way more heat wearing an Angular shirt and going to lunch where React devs are than I think somebody wearing a React shirt would get going to ngConf. So I think you're in a safe space with the Angular guys. We're just happy to be here, right? We're like Charlie Bucket, and we're just happy to be there. We're not gonna rock the boat. We're just on the other hand, I'll leave it there. I'm just a little bit tongue in cheek. I think it's funny when people are like, "Oh, Angular, why do you use Angular? Do you hate yourself?" and stuff like that. It's like, yeah, we can talk about that, right? I just refuse to study the code base because it's so garbo. It's true spaghetti code with files that have thousands of lines. Oh man, There's no safe space. There's only pain and desperation. Pro speaking about text. Oh man. Um, One thing that I will say that LLMs will beat us in every day, hands down, is exactly what you're talking about, Abradores. When you've got a messy code base and you want that messy code base to be cleaned up, LLMs are going to help you understand that code base way better than a human is. Like when you talk about a human reading code, a human's context is about the size of the screen that they're reading on, right? So the amount of context I can keep in memory about this code is about the size of the screen. That's why keeping methods small and keeping code self-documenting is important. It's not because of anything more than the fact that it helps humans, right? LLMs don't have that issue. LLM's context is really the size of the context window. So if you give an LLM a bigger context window, it can understand and ingest more code. I use LLMs all the time with code bases at work when they ask me, hey, can you go help this team? They're struggling with this problem. The first thing I do is I go pull the repo and I throw it into an LLM and I'm like, hey, this is the problem that I was sent here to help with. Help me find the hot points in the code, right? The hot spots in the code. And then once I do that, I start what are the correlations between these hotspots and just questions like that help me understand the code base way faster than me going in and trying to read the code myself. Claude, fix the code base, makes no mistakes. I just change it every day. Do I know what I'm doing? Well, not really, but I didn't get fired yet. Then that means you're successful, right? One thing I want to do is take a look at what we got back. So it picked up Salt Lake City being MST, Mountain Time Zone, picked up OKC being Central, LA Pacific, New York Eastern, and Beantown Eastern. I didn't ask anything else here. These are all randomly generated times. So the goal was going to be to modify that function to use the current time and convert it to the appropriate time zone. So that will be the next goal, but I do need to end. My wife got home about a half hour ago. I could hear my dogs going crazy. Thank you all for being here. Thank you all for the comments. Next week, we'll keep digging into this agent. I'm very interested in this small agent. It's been very fascinating to me. And we'll take a look at what we can do with that. Hey, Michael, good to see you. We'll see you guys all next week. Have a good weekend.